Thank you, Brian. I had a plan to introduce myself, but I think Brian already have a very nice introduction of mine, so I'm going to just skip that and just jump into the my presentation. My internet is a little bit weak, so I'm just gonna turn off my camera. I think it will be better for the whole presentation. I'm just yes. So the talk I will have today is going to be based on my PhD thesis that you can see the title here, Establishment and Early Management of Young Forest in Sweden. And I know probably you are already thinking that it's a broad area, and yes, it is. And that's why I narrowed it down to stand structure, spatial design, and pre-commercial thinning. And the thesis is just summary of summary of this 4 paper that I worked on. And my today's presentation will be more like a popular presentation, so you are not expecting really like scientific graphs and figures. Rather, my aim is to deliver a kind of like main findings or summary of the paper, so you can get the idea about the overall findings. And you can see that I work with a bunch of researchers in these papers. So I will kind of go back and forth with I and we when I address my presentation and all the research questions. Okay, so the first thing, why we even need to care about early forest management, right? So if we look at the full rotation of a stand, that start with the final felling, followed by soil preparation and regeneration establishment, and then pre-commercial thinning, and 1 to few thinnings in the stand, depending on the stand. And in Sweden, it's usually like the rotation is 60 to 80 years. But if I zoom in this part, like the young stand and establishment part, it occupies a very short period of time compared to the whole rotation. But future stand structure, future production, profitability, different ecological and so many ecosystem services depend how you manage this young stand. And considering that, in my research, I investigate that how we can manage this young stand to combine all the services that we can get from a forest. So I divided my work into 4 parts. So in the first part of my work, I looked on stand structure and species composition of young forest. And, I think it's important to know your young forest before you do any of the silvicultural treatment or future or any treatment for your future stand structure. So at first, I looked on the stand structure and species composition of young forest, and then second, I looked on the potential of using rectangular planting design during or establishment to improve regeneration chain and also facilitated young stand management. And furthermore, I also work on pre-commercial thinning to combine forage production for ungulates and also volume production of the main stems. And finally, I also looked the pre-commercial thinning potential to combine timber production, profitability, and other ecosystem services. Okay, I'm just starting with the first research question, where my main aim was to investigate the species composition of the young stand. When I say young stand, it's 1 to 4 meters in height. And I wanted to look that when the forest owner plant the trees in regeneration, is the young stand represent the same species composition during the regeneration or not? And in Sweden, Norway spruce and Scotch pine are the main 2 species that forest owners plant during regeneration. And it's often like the species composition change in young forest because of the browsing, mortality, drought, and so many other issues that's influencing the regeneration success. But we wanted to check that how it looks like, how much the species composition change in a national scale. And to do that, we used a national inventory data for the young stand, like 1 to 4 meter height stand. And in Swedish, it's called äbin data. And if I translate it, is moose browsing data. So all the green dots that you can see in this map are the stand that was inventoried and analyzed in this study. It's pretty much covered all over the Sweden, except the mountain and some water bodies and a small island here because there is no moose inventory there. So in each stand there are plots, and the data was collected in a plot wise. So when the field crews were doing the inventory, they actually recorded which species was used during regeneration. And based on that information, we calculated the species composition in regeneration. And in the young stand with the plot inventory, there is also information about species occurrence, their browsing information, and so on. And based on that data, we calculated the species composition of young forest. And just to mention that Norway spruce is mostly planted in the southern Sweden and Scotch pine in the northern Sweden. So when we look on the regeneration species composition in young forest, in regeneration, it was mostly either Scotch pine or Norway spruce. I mean, like mostly conifer dominated, right? But when we looked at the species composition in young forest, neither Norway spruce nor Scotch pine was dominant. Rather, it was a mixed forest dominant stand in young forest. So here is a quick look how it looks like all over Sweden. So if I take northern Sweden as an example, you can see in regeneration, it's pine and spruce that was used, and this black part is some other species and some that there is no planting was done. But when it comes to mixed forest, you can see the proportion of pine, what was in regeneration and what we found in young forest. It's mostly like the mixed forest that was dominant. Either it's pure mixed or conifer dominated mixed forest or broadleaf dominated mixed forest. And the scenario was same in central and southern Sweden. Only when it comes to southern Sweden, the dominant species in regeneration was Norway spruce, and central Sweden kind of 50-50. So the main findings that species composition has changed than what the forest owner aimed for, right? So this means like if this is the case, then maybe we don't need to plant seedlings everywhere. We can plant less and rely on natural regeneration if this is the case, that we get mixed forest out of this regeneration program. Because this result show that it's a loss of lot of money that we can save and maybe use for I don't know, seedling quality improvement and other things. And also other point to mention that sometimes also a tradition that you plant Scotch pine in northern Sweden and Norway spruce in southern Sweden. And then the argument of the forest owner to plant Norway spruce in southern Sweden, because Norway spruce not usually browsed by the ungulates, but still in northern Sweden, forest owners are planting Scotch pine despite all the browsing. So maybe the forest owner should more look after the site suitability for the species than the tradition. And maybe some of you will argue that it's good that we are getting mixed forest. That's like good for the biodiversity and future uncertainties related to climate change. And I'm fully agree with that, and I'm not denying it. The idea of this research was to show that we are not getting what we are intent for. And although this change in species composition, we are getting a lot of mixed forest, that's true, but we are also losing like Scotch pine, you know, because of this high browsing. And in southern Sweden, in young forest, there is almost no pine. And that could be that not good for many of the biodiversity that's dependent on Scotch pine. And Scotch pine is one of the important economic species, so it will also impact on the future wood supply in the forest industries. So the main conclusion that maybe we should need to be aware more about the regeneration and take initiative to have a more successful regeneration than losing all the economic value, and also keep the balance in the forest, wood supply in the forest. Okay, moving to the next research question. So in Sweden, it's well practiced that they use square planting design, like 2 by 2 meter distance when they plant trees. But many of the researchers outside Sweden showed that rectangular planting design had no effect on mostly like volume production and also wood quality. And rectangular planting design can provide so much benefits to facilitated forest management that I will talk later. So our idea was that to do a study to show that how rectangular planting design affecting the growth and production of Swedish forest, and if there is no effect of rectangular planting design, how we can take the advantage of planting in a rectangular way for forest management. And to do that, we used a rectangular planting design experiment that located 3 parts of Sweden: lodgepole pine in the north, Scotch pine in central Sweden, and Norway spruce in southern Sweden. And the experiment was established with 5 different planting designs, with the traditional one 2 by 2 meter, and 4 other rectangular planting design. So the idea of rectangular planting design is that you'll have same number of trees per unit area, only the spatial position of planting trees will change. For example, if I take 0.8 by 5 as an example, so the distance between trees within the row is 0.8 meter, and between the rows is 5 meter. But number of trees here and here is the same, and it's the same rule for other treatment. And the experiment was established in mid-80s, and when we collect or inventoried the site, it was mid-rotation. And yeah, there were 2,500 trees per hectare in this plots. Okay, and in the mid-rotation, we looked at some of the stand characteristics like growth and production, individual diameter distribution, spatial heterogeneity, and we calculated Gini index for that in a stand-wise, and also ovality, branch thickness, and leaving crown height, and also height diameter ratio. And we compare all these stand characteristics between the square planting design and different rectangular planting design. And we found no difference in any of the species in different locations of Sweden. So this means using rectangular planting design, you can choose the planting spot when you plant the seedlings. So in 2x2 or in a square planting design, like more like a fixed pattern, maybe in 2-meter distance, you find the spot is not really suitable for planting the seedlings, or it's rocky, or any kind of things that's not good for seedling survival. And many of the studies shows that how important the microsite condition for the survival of seedlings. So using rectangular planting design, we can improve, there is a potential to improve the regeneration success. And as rectangular planting design has no effect, maybe we can also test group planting. And the group planting, you can think that it will reduce the time of planting seedlings than traditional row planting. And that can also influence the cost in regeneration chain. And also you can only do scarification in a certain area and remain other area undisturbed. That will also help, many ecosystem services. And third one that I want to mention, that in Sweden, all of the forest operations usually done by machinery, machines, except pre-commercial thinning. But if we use rectangular planting design and create the corridor through it, we can actually use machines to do pre-commercial thinning using that corridor. And some of the very few, although like researchers from Nordic countries showed that using pre-commercial thinning, using machines in pre-commercial thinning is more efficient than the traditional way, and that's way we can also reduce the cost of this regeneration chain. That is, I think, one of the questions that is important in Nordic countries to reduce the regeneration chain costs. So it has the potential to help on that issue. Moreover, it can also be helpful in soil scarification or soil preparation. You can just do the soil scarification in the rows, not all over. And then finally, like when the commercial thinning is done, then the strip road is created for thinning. But if we use rectangular planting design, the corridor will be there from the beginning, and it can be used for any of the operation. And when we create a strip road during thinning, it can damage to the remaining trees, and also it increases the storm damage risk, right? So we can also avoid that by using rectangular planting design. Okay, I'm moving to the third research question, where I looked that if can we use pre-commercial thinning in a Norway spruce birch mix stand to combine forage production and volume production of the main crop Norway spruce. So in southern Sweden, as I mentioned earlier, that Norway spruce like dominant planting trees. And in this plantation, natural regeneration of birch is very, very abundant. And sometimes it could be 10,000 trees per hectare. And they are usually removed during pre-commercial thinning to have a monoculture. But birch is a very good source of forage for ungulates, and it has a high browsing tolerance than Scotch pine, which is other favorite food or like available food for ungulates. So our idea was to use that resources like birch in the young stand to supply forage for ungulates, because there is a conflict of interest always between ecologist and forester, that how much or how many ungulates need to be kept in the forest. So we more wanted to combine both sides by doing pre-commercial thinning. And to do that, we used a pre-commercial thinning experiment that's located in southern Sweden, very south of Sweden. And the experiment was established in 2013 and 14. And the first pre-commercial thinning was done when Norway spruce was 1 to 2 meter in height, and birch was 2 to 3 meter in height. An experiment was established with one control, so there was no pre-commercial thinning done, and 3 different treatments. So the first one was PCT total. So we removed everything except 2,000 Norway spruce per hectare. And there is the second one, PCT spot. So there was like 2,000 Norway spruce per hectare. And in each Norway spruce, there is like 0.7 meter radius around the Norway spruce, and we removed everything within that area, and rest of the broadleaves were there. And the last one, PCT mixed, so we had 2,000 Norway spruce per hectare, and we also kept 2,000 birch per hectare and removed all other broadleaves. So there are 4,000 trees per hectare there. And after 3 growing, like the inventory was done every year, and after 3 growing season, we calculated the growth of individual, we calculate the volume production of individual trees, so the Norway spruce, and also we calculate the forage production from each treatment and browsing as well. And after 3 growing season, we found that there is no difference between PCT mixed and PCT total in terms of the volume production of Norway spruce. And also from the PCT mixed, we got the abundance of forage for ungulates. But after 3 growing season, there is also like lots of stump sprout there. And so in terms of forage, we also can use PCT total. But if we consider like long-term development of the mixed forest and other benefits, then there is also option to mixed forest. So the main conclusion here that this PCT mixed like 2,000 Norway spruce and 2,000 birch in a young stand has the potential to provide forage, and it's also not hampering the volume production of Norway spruce. Okay, with that, I'm moving to the last research question that I answered in my research. So in this study, I wanted to look at the long-term effect of pre-commercial thinning for Norway spruce, and also effect of pre-commercial thinning to develop mixture of Norway spruce and birch, and how we can combine production, profit, and other ecosystem services. So as I already mentioned, that birch are generally removed during pre-commercial thinning. But recently, the law is that if you want to certify your forest in Sweden, there must have to be 10% broadleaves in your stand in southern Sweden to be certified, and also 5% broadleaves in the northern Sweden during the final felling to be certified. So that's why there is a growing interest to develop a mixed forest. And also the other reason is like all the ecosystem services. So yes, so we wanted to check, but of course there is also the issue that mixed forest might lower the production because of the lower timber value of birch and so on. So we wanted to investigate, or we wanted to test that if we use different pre-commercial thinning, can we like combine all these things together? And second question is that pre-commercial thinning is recommended and very well practiced in Sweden. But the main question is there, like when to do pre-commercial thinning, because there is pros and cons in early and late pre-commercial thinning. And often it's recommended to do kind of in between, like when the trees are 2 to 3 meters in height. But there are like very few scientific evidences for Norway spruce that how this timing effect on the effect in long term on the production or economy of Norway spruce. There are few studies on Scotch pine, but not in Norway spruce. So we wanted to test that how the timing effect on the long-term production of Norway spruce. And to do that, we used the same experiment that I used to answer the third research question I showed you a few minutes ago. And only one more site was added to there. And yeah, you remember there's 4 treatment, and after 3 to 6 growing season, depending on the sites, a second pre-commercial thinning was done to test the timing effect and also create a mixture to develop over time. And I'm coming to the treatment to explain you. So there was a control in the first pre-commercial thinning, and half of the area was remained as a control in second pre-commercial thinning. And in the second half, a pre-commercial thinning was done, and we call it PCT late, because when this pre-commercial thinning was done, the Norway spruce was like 4.5 to 6 meters in height. So it's pretty late in their standard. And then we have this PCT total, if you remember, 2,000 Norway spruce per hectare. We named it PCT early because when the pre-commercial thinning was done, Norway spruce was 1 to 2 meters in height. And half of it was remained as a PCT early. And you can imagine that after 3 growing season, there will be lots of stem sprouts there from these broadleaf stems, right? And there are also some studies show that this stem sprouts affect on the production or growth of this main stems. So in one treatment, like half of the PCT total, we removed the stem sprout from there. And then we have left this PCT spot and PCT mixed, and combining these 2 treatments, these 2 mixed stand, we developed or established 3 new treatments. The first one is like, of course, mixture of Norway spruce and birch, and we named it mixed stands with 1,000 Norway spruce and 1,000 birch. And second was PCT or mixed spars with 500 Norway spruce and 500 birch. And third one was monoculture of birch with 2,000 birches per hectare. but in the analysis we didn't use birch because of some missing data. All right, so after collecting the data, we feed the data into a decision support system called Eureka that was developed by SLU for the forest planning in Swedish forest condition. And it's available for all the main species there. And yeah, it's developed based on a lot of growth and yield model, of course, and it has different, it's called interface. And I use the one called PlanWise, where you feed your data and each treatment here considered as a single stand. And then it gives you different management options to manage your stand, and based on your objective, it has a like optimization program on it. It decided the best management plan for you. For our case, the final output was the net present value. So it decided based on the highest net present value. And we did the simulation to develop the stand over a full rotation and also to get the land expectation value and production of the stands. Okay, so now it's time to check how PCT influence on the long-term development of monoculture. And to do that, we compare the PCT and no-PCT stands of Norway spruce in terms of mean annual increment and land expectation value. And for the time and also for the simplicity, I'm just going to show you the result from the land expectation value, or like the economic part. I think that's what we aim for in business as usual system. So we found that there is always a higher economy or profitability in PCT stand than no PCT stand in all the sites. So this indicates that the pre-commercial thinning increases the profitability in long run, although it's the initial cost, but it's pay you back in long run. And then the main question is when to do pre-commercial thinning, right? And we compare between early and late. And some of the early studies on Scotch pine shows that early PCT has a higher income than late PCT, because then when the trees are more thinner, then you need less cost to do pre-commercial thinning, and early pre-commercial thinning also influence increase the growth of the trees. But in our case, for the Norway spruce, in 3 sites out of 4, we found almost no difference of timing on the land expectation value or profitability. And the reason could be that we got like higher income in PCT late during thinning from the PCT late, and also in the PCT early, we had to do like understory vegetation cleaning, that also very expensive. So that might compensate and end up with almost no effect of timing. But in one side, we found higher profitability in doing late pre-commercial thinning. But for this site, the plot location of the PCT late was in a slope, like lower slope. So yeah, my idea or assumption that because of that, it might get more nutrient, and maybe the soil fertility increases and helps to grow Norway spruce more there. So from this result, that one thing that it's very much contradicts what we found in what earlier studies found in Scotch pine, right? So this also shows that the effect of timing of pre-commercial thinning is not that straightforward that we thought before. It could be different for different species and site condition. But it is like a study from one side, but we need more study to reach in a concrete recommendation. But this is just this is of course a map for the forest owner to think about the pre-commercial thinning and when to do based on different species. And we also looked how the sprout removal affect on the long-term profitability, and we compare their land expectation value with PCT early and PCT late. And it was like fluctuated between sites, but effect was very little compared to the early and late. All right, and moving to the last part, and in the last part we also compare the production and profitability between Norway spruce monoculture and the mixed forest in the long run. And from based on our simulation result, but we also compare some of the ecosystem services based on earlier literature. Yes. So first we compare the mean annual increment, and we found that mean annual increment was always lower in mixed stand than the spruce monoculture. And that's kind of expected because of the growth pattern or different growth pattern of these two species. You know, Norway spruce shade tolerant and slow growing in the beginning and then started to grow fast at late. And on the other hand, birch is like fast growing at the beginning and culmination is earlier than Norway spruce, and that kind of can give the lower mean annual increment in mixed forest. Then we compare the land expectation value, and land expectation value was lower in mixed spruce compared to the Norway spruce. But when you compare mixed dense and with the Norway spruce monoculture, in one side it was more or less similar with Norway spruce, and in two sides it was higher than Norway spruce, and in the last side it was lower than mixed forest. But in this last side, when the simulation began, the height and diameter growth was lower in Norway spruce compared to the other. That might gives the lower land expectation value at the end. So my guess here to have a lower land expectation value could be the very low density of Norway spruce, because here, like, you know, the 1000 Norway spruce kind of give more or less same land expectation value as Norway spruce, but here there is only 500 Norway spruce per hectare. That can makes difference, because during the final felling in the mixed forest, Norway spruce was dominant, but there is still more than 10% birch in the stand. So yeah, that could be the reason of the variation between here and there. Okay, so now I'm gonna give you kind of like, I'll compare, we also compare the other ecosystem services between Norway spruce and mixed forest. And from the earlier literature, we found that mixed forests provide more protection against pests and pathogens and more stand stability and increases biodiversity. It has more recreational value than Norway spruce monoculture. And also it's considered as insurance for future timber market uncertainty. and also it improves nutrition cycling and water quality and so on. So the point is that all the benefits we can get from this mixed forest, we couldn't include that in the simulation, right? So although in some site we might have a lower economy of mixed forest, but combining all the benefits that we can get from a mixed forest. So my recommendation is from this study that mixed forest is not always as bad as we think in terms of the production, and it can trade off between the production and all the other services that we can get from the mixed forest. So now I'm gonna summarize and give you some messages in general that you can take with you. So the first one is that species composition has changed in young forest than what the forest owner intended for. And as rectangular planting design has no effect on growth and quality of the conifer trees in Sweden, it can be used to improve regeneration chain and facilitated other management programs. And the third one, that it is possible to use pre-commercial thinning in a Norway spruce birch to combine forage for ungulates and maintain the volume production of the trees. And pre-commercial thinning increases the profitability of Norway spruce in long term. And timing of pre-commercial thinning has very little effect on the production and profitability. So as long as forest owner do the pre-commercial thinning, they can choose when to do the pre-commercial thinning, at least in the sites that where we conducted the study. And lastly, that some form of mixed forest, like in our case, keeping 1,000 Norway spruce and 1,000 birch, can trade off between profitable production and multiple ecosystem services in long term. So with that, I want to draw a general conclusion that it is possible to combine production, profitability, ecological ecosystem services by managing the young stand. So thank you everyone for being here, and I'm just open for questions and discussions.